Hi guys, there were a couple of questions from section 3.1. The first one is number 19. So basically we're asked to do a couple of things with a function we're given. G of x equals to x cubed minus 12x plus 5. I'm sure there's some examples in the book about the process. So hopefully sometimes it does take a little work to get to to answer the question. So there are two questions for this function. First of all, find the critical values, and then also to see if there are any relative extrema, which means relative max, relative mean. So to find the critical values, first thing, of course, we need the derivative, which is in this case 3x squared minus 12. So to find, always remember critical, I'm just going to put CV for critical values. So to find critical value of any function, you take the derivative, and then you simply set it equal to 0 and solve for x. And that's how you always find your critical values. Take the derivative of the function, set it equal to 0, and solve for x. So of course, in this case, our derivative is 3x squared minus 12. So as we set that equals 0, I'm sure that takes you back to college algebra. That's a quadratic equation. I'm going to go ahead and do this square root property. So first, I'll move the negative 12 over. And then to isolate the x squared, we'll divide by 3, which of course implies x squared equals to 4. And I'm sure you remember from your college algebra, by the square root property, that's x is plus or minus a square. Don't forget the plus or minus, guys. Anytime you get rid of square by the square root property, you'll always have two answers. And of course, 4 plus or minus square root of 4, which become plus or minus 2. Okay, so those are your two critical values. Now to answer, this was part A. Now for part B, to find relative max or minimum, we need to take the critical values and do what's called the sign chart. We'll just basically locate the critical values on number line. And then we're going to take a test value. Actually, this for the next problem, number 33, they do ask for the actual where it's increasing, decreasing. So every time you split your number line and the critical values, that kind of split the number line into so many sections. So this one goes from negative infinity to negative 2, negative 2 to 2, and then 2 to infinity. So all you got to do is take a test value in each interval. It doesn't matter what value, as long as it's there, and then evaluate the derivative at that value, okay? And that tells you the sign. So let's suppose we go to the first interval. So I can take negative 3. So we're going to, this is called the test value because we're about to test it. So if you compute g prime of negative 3, which is going to be, again, going to your g prime of x, replacing all the x's with negative 3. And that becomes 9, 27 minus 2, which is 15, which is positive. So that tells you basically your derivative is positive there. And by the way, this also means the function is increasing. Remember, when derivative is positive, it's increasing, which we'll talk about that in next problem. And then also in the next interval, negative 2 to 2, always take advantage of 0. If that's your, you can use that as a test value. Of course, 0 is between negative 2 and 2. So we can also evaluate g prime of 0, which becomes, again, 3 times 0 squared minus 12, which of course is negative 12, which is like negative. So we know our derivative is negative here, which by the way means the function is decreasing. And finally, let me go move it up here. Finally, so we already got the critical values. I'm going to erase part A. So the critical values are 2 and negative 2. So to answer part B, we split the number line at those values. And then we'll just look at the sign of the derivative over each of these intervals, okay? So finally, 2 to infinity, we can take 3. So I'm just going to evaluate from here. I'm going to go up here. G prime of 3, which again is 3 times 3 squared minus 12, which again is 27 minus 12, which again is 15, which again is positive. So now you have also your derivative positive there, okay? So as you can see, when the derivative changes from, this is called the first derivative test. So if you read the section carefully, they talk about that. So when derivative changes from positive to negative, which means your function is increasing, then become decreasing. So you have a relative maximum at negative 2. We'll find the exact point. And also when it goes from decreasing to increasing, obviously that gives you the relative minimum, okay? So this is what they call first derivative test. So we have a relative maximum at negative 2. We're going to have to find a y value, and of course, relative minimum at 2. Now, the final step is to get the actual value, the actual point where your relative maximum minimum happens. And to do that, all you got to do is basically go to the original function, okay? So I'm just going to let you check that. So we have a relative maximum at, now it's going to be negative 2 comma. Now to find, I'm just going to put g. Now don't forget, this is where you go to original function. Of course, the y value is always the function value, g of negative 2, which of course, as you plug in negative 2 in the original function, that should tell you negative 2 comma 21. Okay, so I'll let you check the arithmetic there. So there's your point where you have the relative maximum. Now, of course, relative minimum is going to be at 2 comma, again, g of 2. This is where you go to original function, not g prime, but g. So if you go plug in 2 in place of x in all your in place of x in your g function, you will basically end up with, I believe, because I plugged it in, negative 11. So 2 comma negative 11 will give you your relative minimum. Okay, so again, I'm sure there are some more examples in the section, so you might want to look at them also. Okay, so I'm going to go ahead and stop this for this one and then make another video for the next problem.